Okay. Now, when you graph an inverse, here's an easier way to do it. The thing that I told you would make everything easier in life today. By being symmetrical around the line y equals x, what that essentially means is that the coordinates are going to flip, which means the xy coordinates of your inverse are going to be just the opposite of what they were in your original. Negative 5, 1, 1, 2, 3, 3, 1, 4, negative 5, positive 5. Let's plot those. Negative 5, 1. Oh, 1, 2, 3, 3, 1, 4. It will. I'm just doing something wrong. Let me think for a second. Negative 5, 1. 1. Oh, I just put it on the wrong side. 1, 2 is here. Not over there. 1, 2, 3, 3, 1, 4, negative 5, 5. Connect your dots. And you can see how it is symmetrical. Yes. This should be over here. Again, I did not do it very well. Just switch the x and the y coordinates. There we go. Voila. Yeah. Well, they won't all touch. These happen to because no. Yeah. Oh well, the touching isn't what matters. The fact is, our new one does not pass the vertical line test because our original doesn't pass the horizontal line test. But just for graphing purposes, that's what it would look like. So, that being said, I hope you still have your homework out because numbers 42 and 46 we can now graph. Actually, let's just do 46. 46. I want you to take a second and on your paper, graph the original, x cubed plus 1 for number 46. You can use an XY chart. You can do any of that stuff. X cubed plus 1. If you are going to use an XY chart, you should start at 0 because nothing is being added or subtracted directly to the x cubed. Let's graph x cubed plus 1. It should look something like that when you're done with it. And when you're done with that, try to graph the inverse. Just flip the coordinates and graph those plot points. Okay. When you graph those coordinates, it should look something like that. And hopefully you can see the symmetry. If anybody happen to walk out here and check they're going to buy, I'm not going to matter to you, but if you did, make sure you bring that back. The check they're going to buy, yeah. Problems with that graphing, so there's a few that we can do to And I know this one wasn't required, but once you get confident with that, try to go over to number 36 and do the same thing. Number 36 on your foot. Try to take off coordinates straight up your graph, flip them, and you can graph the input. Try to sketch the graph at number 36. That's 36. This is 42. That is making graph. 36. Try to sketch 36. You're welcome to check your answer to 46 on the board. I've got it drawn up there. I think you could skip it to the but I think 36 is easier than 46. Take off the coordinates that you can, flip them, off their new coordinates, now the new. Yeah, that's what you do. You don't have to. It's easier to visualize it. You don't have to. Now, once you've gotten the ability to sketch these, part C of 46, I'm going back to this one now, should have been much easier, because now to find the domain and range, you can just look at it. Domain, negative infinity to positive infinity. Range, negative infinity to positive infinity. That's it. 42, I'm going to do parts B and C up here for you on 42, and you can just kind of follow along. I don't even necessarily care if you write it down. Just make sure you understand what I'm about to do. 42, if you were to graph this, that's a parabola shifted down 1, correct? Correct, good. Now, it only wants the left-hand portion, less than 0. So it's going to look something like this. Now, your inverse, let's say we wanted to find an XY chart. Where would I start my XY chart for 42? Is there anything being added or subtracted directly to the x squared? But is that inside the function? No, that's separate, so nothing. So we're going to start it at 0. The only difference is, do I have to bother going in the positive direction? No, because all it wants is the negative. So I'm going to go 0, negative 1, negative 2. And I'll go negative 3 just for the heck of it. Plug those in. 0 squared minus 1, negative 1, 0, 3, 8. Plot them. 0, 1, negative 1, 0, blah, blah. You're there. Fish. Now, to find the coordinates of my inverse for that, I'm going to flip them. -1, 0, 0, -1, 3, -2, 8, -3. -1, 0, 0, -1, 3, -2, and 8, -3. It doesn't look great, but there it is. Now, if you're wondering, and it's awesome if you are wondering this, when you actually found the inverse of this, you should have gotten, I think it's square root of x plus 1. And you should have been thinking, or at least I hope you were thinking, the parent, when you're watching me graph that, the parent function for square root of x comes up like this. If it comes upward, why is mine going downward if we didn't have a negative in the problem, so why is it doing that? Well, square root of x. Square root of anything is plus and minus, right? And normally we just default and do the plus side of it. But remember, your x and y coordinates are flipping. So for this one, if all your x's are less than 0, then for the inverse, all of your y's are going to be less than 0, which is why it's only coming out like this, and why there's no top part of it. That's just kind of a FYI. Hopefully you understand it. Okay. Here we go. One quick little thing. Hold on, I'll come right back to this. I'll just bring it up. Nope, no. 1 second. We are going to finish up. If you remember, I changed the numbers on yesterday's assignments. We're going to finish those up now with our newfound knowledge. We skipped this section. Now, the first two, this one and this one, are just like we did the other day, because they gave us charts. Inside out, G of 1. This column is G. So G of 1 is, here's 1, and what is it? 1. At G of 1, Y is 1. So G of 1 is 1, so we're going to substitute that in. What is F of 1? 5. And you're done with that one. Go to the other one. F of -1. F of -1 is +1. So now I need G of +1, and that is 1. Same thing here. Inside out. G of 10, -1. I'm actually going for some audible responses here. -1. Now, this is the only place where it's different. Remember, when you have an inverse, your values are switched. So instead of looking for an x value of -1, we're now looking for a y value of -1 because it's an inverse. So, 2. And the answer would be 2. You are going to have to do something like that in just a second. You'll also have to do something like this. It's going to give you 3 functions, and it's going to say, find these compositions that they ask for above. So, for instance, f of g of 0. Well, g of 0, I come down here. Here's g of x. G of 0, that's 0 minus 1 is -1. So f of -1 is 2, -2 minus 5, -7. Boom. Now, this one, there's 2 ways to do it for an inverse. A, you could find the inverse. So we go to the f function, find the inverse. So that's x equals 2y minus 5. X plus 5 equals 2y divided by 2. And you get your inverse, right? You found it. And you could plug 1 into that. 1 plus 6 over 2 equals 3. Boom, you're done. Another way to do it, again, when it's an inverse, this is no longer an x value. What is it? A y value. So you could just take your function, and instead of plugging 1 in, set it equal to 1. Add 5 to the other side, divide by 2, and again, you get 3. And it's the same thing either way. I don't think you have one like this. This is the same thing, it just goes one step further. So that being said, go back and do, you've already done up to 50. Pretty much all I need you to do now is 54, 58, and 62. And, wait for it, there's only 3 problems. I'm going to give you a deadline. I need this in about 10 minutes. I'll come around and assist, but I need you to hand this in about 10 minutes. It's a great problem. You can do it on the same speed if you want to. Put it on the same homework. In fact, I encourage you to do that. You turn it all at once. When you're done, you can this. Your entire homework assignment to do. That would be the original assignment. I will do it. -1. You're done. Just turn it in. Some 60 here, the functions you need to answer because you are right above them. The functions you need to answer number 62 are right above them. Yeah, I didn't need it. Well, see, when I did it on Fri, I kind of figured it well. You got another 3 or 4 minutes to wrap this up and turn it in, please? Today is the last section. What we're about to do is the last section of this chapter. I've already told you we won't be here Monday. So we'll plan on reviewing my Tuesday section on Wednesday. I don't take questions on test days, but we can see up and see some more time to test. Even though our test isn't until Wednesday, I encourage you to look over this stuff over the weekend, so if you do have questions, you can ask on Tuesday during the review day. That way you're not stuck in the notes. You can always think still early after you go to school. Or you can just add it, but I'm going to go with you can, but I'm not promising you. I mean, sometimes I'm not going to. But you check these. Okay. Make sure we get those turned in. Here we go. Today's lesson. Today is basically a geometry flashback. Everything we're doing today, to a point, is something you've already done in geometry. We're just reviewing it because you are going to need it this year. 1.9. The first one, you're going to need, I think, 3 formulas. Distance formula. First bunch of problems you have is literally just distance, which is x2 minus x1 squared plus y2 minus y1 squared. Then you just got to remember how to do it. I'll just jump down and do number 15. That will be the hardest one on the page because of all the radicals. x2, negative radical 3. x1, 3 radical 3 squared. y2, 4 radical 5. y1, radical 5. Negative 1 radical 3 minus 3 radical 3 is negative 4 radical 3. 4 minus 1 radical 5 is 3 radical 5. Negative 4, when you square these, make sure you do it one piece at a time. Negative 4 squared is 16. What? Go down. Yeah. I'll go back and do it. Radical 3 squared is 3. 3 squared is 9. Radical 5 squared is 5. And then add those up. I believe it's 92. And then you're done. I chose this one because if there's anything on this page that's probably not as up to date in your mind, it's probably the addition, subtraction of radicals. Just remember, if you have a common radical, like radical 3 and radical 5 in this case, you can just add and subtract their coefficients. And where I got all that. Questions about step 2 through 5 here. Any of these steps somebody wants to ask about, where something came. These can combine to this because imagine it was just negative x minus 3x, so that'd be negative 4x. Same thing. The radical 3's are common, so you can just negative 1 minus 3 give you negative 4. Same thing over here. 4 minus 1 gives you 3. Oh, you thought I was putting them together. My bad. My bad. Other questions from something on this page? Mm-hmm. Yes. Make sure if you do it in your calculator, please make sure you put the negative inside of parentheses before you square it. You should never have, when everything's been squared, you should never have a negative number under here in any way. A square should make that impossible. So if you do, then you're just punching something into the calculator wrong. So beware of that. Yeah, that's fine. Yes, sir. Right here? This one right here? Sure. Imagine it was like this. Imagine instead of radical 3, I had negative x minus 3x. And over here I had 4y minus y. Okay? This is going to give you negative 4x, right? And this is going to give you 3y, because they're common terms, right? Radicals work the same way. This is negative 1 radical 3 minus 3 radical 3 is negative 4 radical 3. Same thing here. 4 radical 5 minus 1 radical 5 is just 3 radical 5. And then when you square it, you square the 4, whenever you square something with a radical, you're just going to get the number. Square the 3, square the radical, then 48 plus 45 is 93. Good. Like when you have to do some reducing. I don't think you'll have to on this section, but the next section you will, and we'll look at that when we get there. Good question. Does anybody want to see one with fractions? Okay. Let's do number 17. Just last block, I figured out how to make my screen take up the whole thing. Isn't that better? I was going to say it. I know, right? Okay. Okay. So, okay, distance formula. Y2, well, I don't know why I start with Y. Let me just start with that. X2, and no, it doesn't matter which one you view as 2 and 1. It doesn't matter. Minus X1 squared plus Y2 minus Y1 squared. 1/3 minus 7/3, to subtract the numerator if you have a common denominator. 6 minus 1. What does negative 6 over 3 reduce to? Negative 2. What does 5 over 5 reduce to? Very good. So that'll be you get radical 5. Questions? No question? None at all? Distance formula. The whole day is kind of like this. Just give you a formula, refresh your memory on it, and we're just going to kind of get going. The second formula I'm going to need you to remember is the midpoint formula. X1 plus X2 over 2, Y1 plus Y2 over 2. Again, I'll pick what I believe to be one of the hardest ones on the page to help you with those, like 29. 29. Your X values are radical 18 and radical 2. And your Y values are negative 4 and positive 4. This is a comma. It's a coordinate. You're finding a coordinate. Yeah, I'll shape it. Well, the Y is easy. Negative 4 plus 4 is 0. 0 over 2 is still 0. The X, I'll give you a hint. Anytime you have an uncommon radical today, it's trying to get you to notice how they simplify so that something will reduce kind of nicely. Does 18 have a perfect square factor? I would only be asking you if the answer was yes. That's right, 9. You could rewrite 18 as radical 9 times radical 2. What's the square root of 9? 3. So this be rewritten as 3 radical 2 plus radical 2 over 2. I've just rewritten this like this. Now, again, common term, that's the same as 4 radical 2 over 2. And you can reduce it. 4 divided by 2 is 2 radical 2, which is your x value. I don't know what's happened. My hand really hurt. Somebody do the voodoo. I'm still finishing the lesson regardless. So put up your dolls. Good. And then there's a handful of you that had me for geometry. I know we can. Is there another one on that page somebody would like to see? Yes, sir. Yeah, that became 4 radical 2 over 2. And then 4 divided by 2 is just 2. Because these are now a common term, so 3 plus 1. Yeah, you always have to imagine a 1 if it's just a radical. Yeah. Other questions? Yeah, that's it. We're done. This is your coordinate right here. Well, we did the y first because it was quicker. Negative 4 plus 4, which is 0. So 0 over 2 is 0. Yeah. No other questions from this page? Great. The last thing we're going to do today, just do it in 3 different ways. Circles. The formula you need for that. You know how much practice it took to get even this legible on this little thing? I can't see what I'm writing. I'm looking somewhere else and writing. It's hard. It's hard to get used to. A little later in the year, I'll be getting you guys this thing to show me problems up here, and you'll see. You'll appreciate it. Okay. Don't forget the center of your circle is given by that's the equation of a circle. It's given by the h and k. Ready? Don't even think about asking your calculator. Keep that head up. And r, well, it's just going to be the square root of this number, equals the radius. And here, all they want you to do literally is just write the equation. So like 37. Yeah, on these it does. It gives you the center and the radius. You just plug them in. So like 37, x minus negative 3, which is the same as plus 3, squared, plus y minus negative 1, which is the same as plus 1, squared, and then your radius squared. Square root of 3 squared is the same as what? Just 3. So you can just take out this middle. Y minus k, yeah. This is 37. We can do another one real quick. How about 39? X minus the negative 4, so that'll be plus 4 squared. Y minus 0. What is y minus 0? Just y. So you don't have. You could write the y minus 0 squared, but you don't have to because it's just minus 0. And then what's 10 squared? There you go. And there's the equation for 39. And that's all there is to those. Plug them in. All there was the equation. Questions? Skipping on. We're going to come back to that one. Graphing. Same thing. What is being subtracted from the x? Negative 3. Remember, it's x minus h. So really, you just always take the opposite of this. So negative 3. What's being subtracted from the y? 2. There's my center. And what's the square root of the last number? And there's my radius. So to graph it, negative 3, 2 is my center. 2 in every direction. There you go. The square root of the last number. 0 to 4. And you've graphed it. Yay! Almost done. You can hear the weekend setting in. You might need me to leave this up there for a second. Going back to the other, they don't ask you to graph here. What they ask is, they say, what is the center and the radius? So, like, let's do 43. What's being subtracted from x? What about from y? What's our radius? Very good. Then they say, what's the domain and range? Now, you might be thinking, how are we going to know that without graphing? And yes, you're more than welcome to graph all of these if you wish. Where is my mouse? There it is. You're more than welcome to graph them, but let's look at another way. If we were just to graph it, what would you say? The domain is -5, -1, and the range is 0 to 4. And you could just eyeball it, give me the domain and range like that. But another way to do it is, you know you're just going to be the radius distance from your center in all directions. So you could, on the other slide, without graphing, just say, first of all, look at your x. Does the x go with the domain or the range? Domain. So your domain is going to be 2 units less than and greater than your x center. So yeah, you could, well, let's do the lower half first. -3 minus 2, -5, -3 plus 2, -1, there's your domain. -5 bracket, comma, -1 bracket. For your range, you use the y value. 2 minus 2 gives you 0 with a bracket. 2 plus 2 gives you a 4 with a bracket. And you can find your domain and things like that. That way you don't have to graph all this. Exactly. Let's look at maybe one more so we make sure we understand how to do that. Let's do number 51. What's being subtracted from x? -1. What's being subtracted from y? What's my radius? Excellent. So for our domain, -1 minus 5. Let me actually write it out here. Domain. -1 plus 5. 4. Now for the range. And you're welcome to graph this and visualize it if that's the way you prefer to do it. 0 minus 5. 0 plus 5. And there's your range. And like I said, if you graph it, you can see it. You're more than welcome to do that. Questions about that slide? It's just 0, 0 center. Nothing's being added or subtracted. Don't worry about that. Okay. You are going to have 2 of these. I love these problems, so much to the fact that I'm cutting your assignment in half just to give you one more of these, because these do everything we're doing today in one fell swoop. To find the center, you find the midpoint of those 2 points. To find the radius, you find the distance, and then you cut it in half. And then for your equation, well, once you have the center and the radius, the equation should be walking apart. So, that being said, I'm going to go ahead and give you your assignment, and I'm going to change it. So don't write it down too quickly. Don't write it down too quickly. Hold on. Give me 1 second. All right. Now, hold on to yourself. An extra one. That means instead of every 4th problem, you're going to do every 6th problem. 2, 8, 14, count by 6s. And I also want 65 and 66. There you go. That is your assignment.